right, so we're here working on dividing some polynomials by using the graph to help us get started, factoring them, and factoring quadratic equations. So if you start out with polynomial, like this wonderful polynomial here, x cubed minus 2x squared, plus 2x squared minus 55x plus 72, you get this sort of thing here. It has lots of ups and downs. And what you'll notice is that there's one of those roots, one of those x-intercepts that's a whole number. The other two roots are these nasty decimals, and that tells me they're probably irrational. So when I see a -9, 0, that means that x equals -9 makes the equation equal 0, and that means that I know that x plus 9 is a factor. So I could take my original polynomial and divide it by x plus 9, and I'll get the other factor. So you have x plus 9. You draw your box to try to help divide with x cubed there. Means this has to be x squared on top. X squared times x makes x cubed. X squared times 9 makes 9x squared. So remember, the outsides of the box multiply to fill in the inside. Now I have 9x squared. The original problem needs to have 2x squared. So I take away 7x squared. Then I think, what times x has to be times -7x to get to -7x squared? -7x times 9 makes -63x. Then I check again. I need to get to -55. So that's adding 8x. That means this needs to be plus 8. X times 8. 8 times 9 is 72, and that checks out the end there. So what I know now is that the original polynomial that I have is actually equivalent to a different polynomial, the factors that I have on the outside of my box. X plus 9 times x squared minus 7x plus 8. Notice that the blue equation lines exactly on top of the red equation, because this blue equation that I'm highlighting is the product of factors that make up the red equation. So that's all you had to do, is we're using the graph to find a rational root, and then we are dividing by the factor. Okay, so let's give it a shot on another problem. So there you go. Second problem on the sheet was 4x cubed minus 67x plus 12. That one's not good. That one's not good. Looks like 4 is the root. So I'm going to divide by x minus 4. So that's my side of my box. 4x cubed goes there. So 4x squared goes on the outside. The outsides multiply to make the insides. So if we multiply here, we get -16x squared. Check up again at the top, but there's no x squareds. That means that if you want, you can imagine a plus 0x squared there. So that would be a positive 16x squared, because a negative and a positive, -16 and +16 add to make 0. Insides add, outsides multiply. X times 16x makes 16x squared. 16x times -4 makes -64x. Check the original polynomial. -64 minus 3 makes -67. X times -3. -3 times -4. Check the original polynomial is 12. So the original polynomial is equal to these two factors on the outside of the box. X minus 4 times 4x squared plus 16x minus 3. And you can see again that they line up exactly on top of each other. So I'm using Desmos. You can use a graphing calculator if you have that in class, and the two graphs will line right up on top of each other if you did it correctly. Okay, last one of this style of question. Oops. Let's clear that out. Great. Okay. So the last one that we have is 3x to the third plus 13x squared plus 50. I only see one root here, negative 5 comma 0. And if I zoom out, I think this one, yeah, see, it only actually has one root. The other roots are imaginary numbers. So anyway, negative 5 comma 0. So let's do the same process. Divide by x plus 5. So that's x plus 5, 3x to the third. So it's x times 3x squared, 5 times 3x squared. I need to get 13, so I take away 2. X times negative 2x gives me negative 2x squared. 5 times negative 2x gives me negative 10. There's no x term there. It's missing, so I need to cancel out all of those. And then I have plus 10. 5 times 10 checks out. And so I have x plus 5, 3x squared, minus 2x plus 10. So we factored them. Okay. Now, very similar idea on the bottom of the sheet. On the bottom of the sheet, we were factoring some quadratics. So on these ones, we don't need to use the graph at all. When you have just a regular quadratic like this, when the a value is equal to 1, you can just think of the numbers that multiply to make the c value and add to make the b value. So two numbers that multiply to make 60 could be 10 and 6. And I chose 10 and 6 because they're 4 apart from each other. I'm going to make that a negative 10 and a positive 6 because that adds to make negative 4. So there's that. Next one on the sheet was w squared minus 11w plus 30. Here we have two numbers that multiply to make 30, like 6 and 5, and that also add to make 11, negative 11. So I'll make them both negative to get to positive 30 and to get to negative 11w. Okay. The next couple problems were a little bit trickier because the a value is not equal to 1. So on these ones, I suggest using your box. You've got 4x squared here, and you've got negative 30 here. A nice technique that you can use is to use the diamond where you multiply a times c, make negative 120x squared, and just write the b value down there. Let's see, how can you get two numbers that multiply to make 120 and add to make 19? Okay, a little bit rusty on this. So 20 and 6, right? Okay, let's think about 120. Is 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24. That's the root. Okay. I said that if you get stuck, like I just got stuck, I just needed to write out the factors until I found the ones that worked. So here we can have 5x, make that a negative, and here we can have 24x, make that a positive. Pop them in the box. And then you're thinking, what's in common with each of the columns and the rows? So that's got a 5 in common. This has a 4x in common. Top row has a 1x in common. Bottom row has a 6 in common. And so you factored it to be 4x minus 5 and x plus 6. Okay, just a couple more. The next one, they use the Greek letter theta to show the problem. It's just another variable, nothing to be scared of. So let's work through it. 8 theta squared and 15 here. I'm going to do the diamond over here. So 8 times 15 is also 120. Am I right there? Yeah. So 120 theta squared and 22 theta. That's looking like 10 times 12, I think. That works. Great. 10 and 12. So here's 5 in common. Let's see, 8 and 12 have a 4 in common, so 4 theta plus 5. Here it's a 2 in common. And then on the bottom, is there anything in common? It's a 3. So our two factors are 4 theta plus 5 and 2 theta plus 3. Great. All right, last one was 5r squared minus 38r minus 18. We can try the same process. 5r squared minus 18. Multiply 5 times 18, you get negative 90r squared. Down here, negative 38r. Okay, what are some ways? 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times 15. I don't think this one is going to work here. 7 doesn't go in, 8 doesn't go in, 9 times 10. And when I look at any of those, none of those add up to the 38, okay? And so it's looking like this is impossible to factor. And so two ways you could check your work if you think it's impossible to factor. One way is to try to graph it, 5r squared minus 38r minus 18. Oops. And Desmos wants me to use x. There you go. And you'll notice that it doesn't go through nice whole numbers. Okay, so there you go. That was the practice quiz. Please let me know if you have any questions and I'll help out.